Hello everyone, welcome back to our channel. In this video, we'll be solving exercise 2.2 of our second chapter, polynomials. Here we have 4 types of questions. So the first one is just finding the value of polynomial. The second one is finding the value of P0, P1, and we just put these values in these polynomials. The third one is checking whether the given numbers are zeros of these given polynomials. And then the fourth one is finding the zeros of the polynomial. So let's begin with our first question, which is finding the value of this particular polynomial at different values of x. How do we solve this question? So the first step is first we are just going to write this polynomial, okay, the given thing. And since this polynomial is in terms of x, okay, so our variable here in this polynomial is x, we are going to write this polynomial as it's a polynomial in x, which is equals to 5x minus 4x squared plus 3. So we are just writing this polynomial over here as a polynomial in x. Now after writing this, we can easily find the value of this particular polynomial for different values of x. So for the first case where we have x is equal to 0, what we can do is we can write this px as p0 since x is 0 in this particular case. And now we are just going to plug in the value 0 in these x. So we have our 5 times our x is 0 minus 4 times our x is again 0. So we have 0 square plus 3, and 5 times 0 is 0 minus 4 times 0 square is also 0 plus 3, and we have our answer as 3, and that's our first question. Now you can try to do the second question by yourself by pausing the video. So in our second question we have x equals to minus 1. For x equals to minus 1, again we have the same polynomial, okay, px equals to 5x minus 4x squared plus 3, because it's given in the question at the beginning. So we have to put the value minus 1 in this particular polynomial px. Now what we are going to get is we have px is minus 1 is going to give us 5 times our x is minus 1 minus 4 times our x is minus 1 whole square plus 3. This is going to be 5 times minus 1 is minus 5 minus 4 times minus 1 square is minus 1 times minus 1 is plus 1 plus 3 equals to, we have minus 5 minus 4 times 1 is minus 4 plus 3. Minus 4 minus 5 is minus 9, minus 9 plus 3 is minus 6. And done, that's our second one. For our third question, we have our x as 2. So we had our x as 2 in our third question here, over here. And then our polynomial is 5x minus 4x squared plus 3, right? We have it here as well. So in case of 2, we have to find the polynomial in terms of 2, which is going to give us, again, our 5 is there, right? It's right there. And our x is 2 in this case, minus 4 times, again, our x is 2, so 2 square plus 3. Now we just multiply these numbers. We are going to get 5 times 2 is 10. Minus 4 times 2 square is 4, so 4 is 16 plus 3. Now 10 minus 16 is minus 6, minus 6 plus 3 is minus 3. So in our first question, what we did is we just wrote the polynomial that is given in the question as px, and then we just plugged in these values 0, negative 1, and 2 in this x and here as well, and we got our answer. That's it, okay? That's the first question. Now let's look at the second question. So in our second question, the polynomials are already given as p in terms of y, right? pt, px, and px. what we need to do is just find the values of these polynomials when the x or the variable is 0 and when it is 1 and when it is 2. Okay, so let's see how we can do that. This is pretty similar to our first question. So we have our py in our question number 1 as py equals to y square minus y plus 1. In our question number 1, only this part was given. We had to write this p in terms of y, right? P bracket y. But in this question, it's already given. It just says that py is y square minus y plus 1. Now, what we need to do is we need to find p0, p1, and p2. And that's pretty simple. So for p0, we put the value 0 in these y. Okay, so py is y square minus y plus 1. So p0 is going to be 0 square minus 0 plus 1, which is equal to 0 minus 0 is 0, 0 plus 1 is 1. And similarly for p1, again we can do the same thing. So we have y is 1 in p1, so y square is going to be 1 square minus y is again 1 plus 1. This is going to be minus 1 plus 1 gets cancelled and 1 square is 1. Let's do the third one. So we need to find the p2. So we have y is 2 in this case, so y square is going to be 2 square minus 2 plus 1, which is going to be 2 square is 4 minus 2 plus 1. This is equals to 3, right? 4 minus 2, 2, 2 plus 1, 3, and done. That's it. Okay, so in the second question, we just put these values 0, 1, and 2 in these questions, and you'll get your answer. So similarly, we can do the second question as well. Again, you can pause the video and try it yourself, and you can check the answer. So let's do the second one. So our second one is a polynomial in terms of t. So we have pt equals to 2 plus t plus 2t square minus t cube. So how do we do this? Again, we need to find p0, p1, and p2. So for p0, the t is going to be 0. So we have 2 plus our t is 0 plus 2 times our t is again 0. So 0 square minus t cube is 0 cube. This is going to be, so 2 plus 0 disappears, right? Plus 2 times 0 square is again 0. So let's write that one. And then we have minus 0 cube is 0. So this is just plain 2, okay? And let's try to find p1 as well. So we have 2 plus t is 1 in this case, and plus 2 again t is 1. So 1 square minus t cube is going to be 1 cube. This is going to be 2 plus 1 is 3 plus 2 times 1 square is 2 minus 1 cube is 1. So 3 plus 2 is 5, 5 minus 1 is 4. Let's find p2 as well. So we have our p2 over here. For p2, again we have our 2 plus our t here, right? This is going to be 2, okay? Because we are doing it for 2. 2 plus 2 times our t square is 2 square minus t cube is 2 cube. So this is going to be 2 plus 2 is 4 plus 2 square is 4. 4 times 2 is 8 minus 2 cube is also 8. So we can again cut this set and that 8, and we get our answer as 4. And that's our second question. Let's try the third question. So our third question is pretty simple. It's just px is x cube. I think we can just do it over here. So we have our third question as px equals to x cube. Again, we need to find the same things, okay? p0, p1, and p2. So p0 is going to be 0 cube, which is 0. And then we need to find p1, which is going to be 1 cube, which is 1. And then for p2, our x is 2. So we have 2 cube, which is going to be 8. Similarly, we can do the fourth question. Again, you can pause the video and try it yourself, and then you can later check the answer. So in our number 4, we have px as x minus 1 and x plus 1. So again we need to find p0, p1 and p2. So p0 is going to be 0 minus 1, 0 plus 1, which is equals to minus 1 times plus 1, which is equal to negative 1. Similarly, we can find p1. So we have p1 as, now our x is going to be 1. So it's going to be 1 minus 1 and then 1 plus 1, which is equal to 1 minus 1 is 0 times 2 is 0. Again, let's find p2. For p2, our x is 2, so 2 minus 1, 2 plus 1. This is equals to 2 times 3, which is equals to 3. And done. Okay, so we had 4 questions, and then we just needed to find p0, p1 and p2, which is just plugging in these values 0, 1 and 2. Okay, we just put these values here in the variables because these polynomials are in terms of these variables, and you get your answer. Now let's do the third one. For the third one, our question is verify whether the following are zeros of the polynomial indicated against them. That's our question, and we have a lot of questions in our question number 3. Okay, the sub questions. To do this question, first we need to know what we mean by zeros of polynomial. Okay, what is zeros of polynomial? And to understand what are zeros of polynomial, we are going to take help of our question number 2. Okay, so we just solved this question number 2. It's over here, and what we found while solving this question number 2 is when you put in these values, we get different numbers. Okay, so when we put 0 in this particular polynomial, we get our answer as 1. When we put 1, we get our answer as 1 again. When we put 2, we get 3. Okay, so when we put these different numbers in our polynomial, we get particular answers. Okay, in terms of numbers 1, 1 and 3. Similarly, in our second case, we got 2, 4 and 4. Now if we look at the third case, in our third polynomial, when we put the value 0 in our polynomial, our answer became 0. Now this is very important. Okay, so when you put a particular number in a polynomial, which is 0 over here, and if you get your answer as 0 over there, then that particular number, in this case is 0, is the 0 of the polynomial. Now there are lots of zeros in this particular case. Let's look at another one. Okay, so in this particular case, in our question number 4, when you put the 0 in the polynomial here, you don't get a 0 as your answer. And if you don't get 0 as your answer, then this 0 is not 0 of this particular polynomial. Okay, so the 0 of the polynomial need not necessarily be 0 itself. In this particular case, in our second question, the 0 of the polynomial was 0 itself, but it's not necessary that that 0 is 0 of the polynomial in all cases. In this particular case, this particular number 0 is not 0 of this polynomial. However, when we put number 1 in this polynomial, you get the value or the answer as 0. And again, if you get your answer as 0, when you put a particular number value, then that particular number, this 1, is the 0 of this polynomial. So the 0 of this particular polynomial in our question number 4, x minus 1, x plus 1, is 1. Okay, this particular number is the 0 of this polynomial. In our question number 3, 0 itself is the 0 of the polynomial. In our question number 1 and 2, we don't get 0 of the polynomial because all the answers are some numbers, they are not 0. Okay, so we have 2, 4, 4 over here. If you get a number or if you put a number over here and if you get your answer as 0, then the number that you put in here is the 0 of the polynomial. Okay, now let's see in our question number 3, we have to check whether these particular numbers are zeros of the given polynomials. Okay, so if you put this value minus 1 over 3 in this particular polynomial and if you get your answer as 0, then yes, it is a 0 of this polynomial, and if you don't get your answer as 0, then it's not 0 of the polynomial. Let's see. Okay, let's just try to do this and I think you will figure it out. Let's start with the first one. So the polynomial in our first question is 3x plus 1, and we have to check whether this minus 1 by 3 is a 0 of this polynomial. We check it by doing this. Okay, so in the place of x you put this number p, so we have minus 1 by 3, so we are plugging this value minus 1 by 3 in x, and we get this as 3 times our x over here is minus 1 by 3, right? So minus 1 by 3, and then we have plus 1. Now we can cut this 3 and that 3, and we get our answer as minus 1 plus 1 is 0. So when you put this number minus 1 by 3 in this particular polynomial, you do get your answer as 0. And when that happens, then this particular number is a 0 of this polynomial. Okay, so in the first one, yes, minus 1 by 3 is a 0 of this polynomial. Now let's see whether 4 over 5 is also a 0 of this particular polynomial. Again, we do the same process. So we have our p, we put the value 4 by 5 in this particular polynomial. So we have a 5 times our x is 4 by 5, and then we have minus pi. Now we can cut this 5 and this 5, and this is going to be 4 minus pi. And we know pi is something like 3.14 something something something. And when you subtract this 4 and pi, which is something like 4 minus 3.14 something, when you subtract this, you're going to get something like 0.9, or if you put 3.14, you might get something like 0.86. But whatever you get, this is not equal to 0. Okay, this number is not 0. And if you don't get 0 at the end, right, the answer, then this number over here that we plugged in is not a 0 of the polynomial, of the given polynomial. So our answer for this second question is going to be no, it's not. 4 over 5 is not a 0 of this polynomial. Okay, now in our question number 3, we have two values. Okay, we need to check for two values whether these are zeros of the polynomial. So before we are just checking one value, so we are trying to see whether these are 0 of these given polynomials. Now we have to check for two values. Let's do the third one. Okay, so in our third one we have 1 and negative 1. So first let's just do plus 1. Okay, so p1, we put this 1 in the given polynomial. Okay, so we have x square minus 1, x square is going to be 1 square minus 1 is equal to 1 minus 1 equals to 0. So we get the answer 0. So indeed this one is 0 of this given polynomial. What about minus 1? Let's see. So if we have something like minus 1, will we get answer 0? Let's see. So again we have x square minus 1. This is going to be minus 1 square minus 1. So our x here is minus 1, so x square is minus 1 square. Minus 1 square is plus 1. Again we have minus 1 over here, so 1 minus 1 is again 0. So minus 1 also gives the answer 0, and so minus 1 is also 0 of this particular polynomial. So in this case, in our question number 3, both 1 and minus 1 are zeros of the polynomial. Okay, so both of them are zeros of the polynomial in question number 3. So a polynomial might have more than one zeros. Okay, so in this case we have two zeros. Similarly, let's see whether our question number 4, whether these numbers minus 1 and 2 are zeros of our polynomial of question number 4. So let's write it over here, okay? It's getting messy. So our question number 4 is px equals to x plus 1 and x minus 2. And we have to put the values x equals to -1 and 2, okay? So first, let's try -1. So we have, instead of x, you just put -1. And you have x is -1 plus 1. Again, x is -1 minus 2, which is equals to -1 plus 1 is 0. When there is nothing, there is multiply, right? And -1, -2 is -3, -3. 0 times -3 is 0. So when you put the value -1, it indeed gives us 0. So -1 is a 0 of the polynomial. What about 2? Let's put 2. So we have, again, x is 2 now, 2 plus 1. And again, 2 minus 2. This is going to be 3 times 2 minus 2 is 0. Again, we get our answer as 0. And so 2 is also 0 of this polynomial. So in our question number 4, both, again, -1 and 2, both are zeros of the given polynomial. Okay, so zeros of px, you could say. Now you can similarly try question number 5 and check whether your answer is correct or not. Okay, it's pretty easy. So question number 5, we have px is x square. We need to check whether x equals to 0 is the 0 of this polynomial. It's pretty simple, okay? So we need to find p0 equals to 0 square is 0. So yes, this is a 0 of the polynomial. Okay, let's do question number 6. So our question number 6, let's do it over here. Question number 6, we have px equals to lx plus m, and we need to check whether x equals to minus m over l is the 0 of this polynomial. So let's put the value minus m over l in the place of x, okay? We are trying to test whether it's a 0. So we have minus m over l here. When you put minus m over l in place of x, so we have l times, here also in place of x, you need to put minus m over l, plus we have our m. We can cut this l and that l, we get negative m plus m, or minus m plus m is 0. So when you put this particular value, you indeed get 0. So this is also 0 of this polynomial, okay? Because it's giving us 0. Let's do question number 7, okay? So in our question number 7, what do we have? Px equals to 3x squared minus 1. So we have px equals to 3x squared minus 1. Let's see which values we need to put. So one of the values is minus 1 over root 3, another is 2 over root 3. So minus 1 over root 3, another is 2 by root 3. Let's see. So again, in the place of x, you put these numbers. So minus 1 over root 3 first. Let's try that one. We have 3 times x square is minus 1 by root 3 whole square minus 1. This is going to be equals to 3. The square of minus is plus, right? Square of negative is positive. So 1 square is 1. Root 3 square is 3. The square root disappears. Minus, we have our 1 over here. Again, we can cut this 3 and that 3. And we get 1 minus 1 is 0. So minus 1 over root 3, okay, this is a 0 of the polynomial. It is a 0 of the given polynomial px. What about 2 over root 3? Let's put that number as well. So we have p 2 over root 3 equals to 3 times our x square, right? So we have 2 over root 3 whole square minus 1. This is going to give us 3 times 2 square is 4, root 3 square is 3 minus 1. 3 cancel, 4 minus 1 is 3. and this is not 0, so this is not a 0 of our polynomial, okay? Only when the answer is 0, it's a 0, right? So 2 over root 3 is not 0 of the given polynomial. Now I think we have a last question, okay? I really want you to try this one, okay? Pause the video for a few seconds and try this one. So if you have tried by now, let's check whether your answer is correct or not. So we have px, this is the 8th question, I think. Px as 2x plus 1, and what was the value again? I think it was 1 over 2. Yes, it's 1 by 2. So we need to check whether 1 by 2 is 0 of this polynomial. Let's put 1 by 2 over here. We have 2 times x is 1 by 2 plus 1. You can cut this 2 and that 2. 1 plus 1 is 2, which is not 0. So 1 over 2 is not a 0 of this polynomial, okay? So it's not a 0 of px. I think your answer should be correct, okay, by now. But if it's not, you can try again. And that's it, okay? So in question number 3, what we did is just verified or checked whether these given numbers are zeros of the given polynomials. And to check it, you just need to plug in the values, and if your answer is 0, then yes, it is a 0 of the polynomial. And if it's not 0, then they are not zeros of the polynomial. Now finally, let's move to our question number 4. So here it is, our question number 4. In question number 4, we need to find the zeros of polynomials in all these cases, okay? So we already have polynomials given in the question. What we need to do is we need to find the values that will give the answer 0, or we need to find the zeros of these polynomials, and so it's pretty easy, okay? Let's see how we can find the zeros of the polynomial. So let's start with our first question. In our first question, we have px equals to x plus 5. How do we find the 0 of this particular polynomial? Which value of x gives the answer of this question as 0? Now, if you think a little bit, you know that if you put minus 5 over here in place of x, you will get your answer 0. And the 0 of this particular polynomial, px, is negative 5, okay? You can intuitively think it like this, or the process to do this is this entire thing px, or this x plus 5, needs to be 0, okay, for a particular value of x, and that value of x is our 0. The way to solve this is you just write px as 0, okay, and then you have our x plus 5 is 0, right, for some value of x, and that value of x is our 0 of the polynomial. Now for what value of x is x plus 5 0, you move this plus 5 to the other side and you get x equals to 0 minus 5, right, which is equals to negative 5, okay? And so the 0, the value of x that gives the end result 0 is negative 5. We can intuitively think about it directly as well, but this is the process, okay? So that when there are complicated questions, you can use the process to find the 0 of a polynomial. What about question number 2? Again, you just equate this to 0 and then you find the value of x, right? So x minus 5 is 0, so x is going to be, when that negative 5 goes there, it becomes positive 5. So when the value of x is 5, so when you put this x as 5, you get the end result as 0, right? 5 minus 5 is 0, so 0 of this polynomial is just 5. So here we can intuitively directly think about it, right? But here it might not be that easy. For what value of x is this entire expression going to be 0? If you put a 1, it's not going to be 0. If you put minus 1, it's not going to be 0. So in these cases, this process helps. So let's do the third one. So we have our px as 2x plus 5, right? So to find the 0 of this polynomial, or for any polynomial, you write that polynomial as 0, okay? The value of that polynomial as 0. And you have px is 2x plus 5 equals to 0. Now we just find the value of x. So 2x is plus 5 becomes minus 5, right? And then we have is just divided by 2, so x is going to be minus 5 by 2, okay? This 2 comes here by 2. So when the value of x is minus 5 by 2, then this entire expression is going to be 0, right? So 2 times minus 5 by 2 plus 5 is going to be 0. 2 cancel, minus 5 plus 5, 0. So when the value of x is minus 5 by 2, the expression is 0, becomes 0. So this is the 0 of our polynomial, okay? Minus 5 by 2. For the fourth question, you can again pause the video and then try it yourself and check whether your answer is correct or not. So our fourth question is px equals to 3x minus 2. So we have our fourth question as px equals to 3x minus 2. I think this is the question. Let's check once more. Yes, 3x minus 2. So again, we have to equate this as 0. So px equals to 0, 3x minus 2 equals to 0. Negative 2 becomes positive 2, right? And then you divide it by 3. So 2 by 3. And that's it, done. X equals to 2 by 3. So 2 by 3 is the 0 of question number 4, or this particular polynomial. What about question number 5? Okay, let's do question number 5. It's pretty easy, okay? All of these questions are very easy. So we have px equals to 3x. So again, px equals to 0. So 3x equals to 0. And then x is going to be 0 by 3, and x is equals to 0. So in this particular case, the 0 of the polynomial is 0 itself. Let's do question number 6. Px equals to ax, a is not equal to 0. So we have px equals to ax, comma, a is not equal to 0. So this is just something that they write in the question, so that the answer does not becomes something of sort of undefined, okay? But you don't need to pay a lot more attention to this, okay? It is important, but it's not necessary that you need to pay attention here. So again, we have px equals to 0. So ax equals to 0. We need to find the value of x. So a goes there. We have 0 by a, and 0 by a is 0. So here again, our 0 of the polynomial is 0 itself, right? Now the importance of this a is not equal to 0 is if a was 0, then it's going to be something like this. Expression is going to be something like 0 by a is 0, and 0 by 0 is undefined, okay? We don't know the value of 0 by 0, right? It could be 1, it could be 2, right? So to remove this contradiction or this thing, the question just mentioned you that a is not equal to 0, okay? And that's it. You don't need to show this, you don't need to write this. You can just do it directly, like for all questions that we have done till now, okay? And you'll get your answer as 0. And that's our 6th question. Now let's do the 7th one. So our 7th one is px equals to cx plus d. Again, here we have c is not equal to 0. This is again similar to the 6th question, okay? And c and d are real numbers, are also contexts that are important but not necessary, okay? So for our 7th question, I'm just going to write px equals to cx plus d. So we have our px as cx plus d. We need to find the 0. We equate this px with 0 itself. We have cx plus d equals to 0. I need to find x, so this d, when it goes there, it becomes negative d, and then we have our x as negative d over c, okay? And so minus d by c is the 0 of our polynomial cx plus d. And that's how you find zeros of the polynomial. You equate the polynomial with 0, and find the value of x, and the value of x that you get at the end is the 0 of the polynomial. So in this entire exercise, what did we learn? So the first thing that we learned is finding the value of polynomial for different values of x. The second question was similar, right? We found the values of these polynomials for different values of y in this case, for t, right? So for 0, 1 and 2, we just plugged in these values. In question number 3, again we did the same thing. We plugged in these values, but an extra thing that we did here is we checked whether the answer is 0, and if the answer was 0, then these values were zeros of the given polynomials. And in our question number 4, we tried to find the zeros of the given polynomials. And that's it. So if you liked our video, please give us a thumbs up and subscribe to our channel for future maths videos.